The topic of this session is applying force, imposed displacement and imposed velocity in radius. The main objective is to demonstrate how to apply loads in quasi-static analysis. There are some guidelines to be followed here. They are: the load cases for a quasi-static analysis can be a force or imposed displacement or a imposed velocity. These loads can be applied by creating a rigid and applying on the master node of the rigid. It is also suggested that the final load should come in 300 milliseconds. That is, the runtime what you are specifying, it should be 300 milliseconds. Also, the load curves should be something like this. That is, for a concentrated load, it should start with 0, 0 and we ramp it and we hold it. And for an imposed displacement, it should start with 0, 0 and we ramp it. And for an imposed velocity, it should be constant. This is not a stone-ridden sentence, like it has to follow these curves. There are some cases where we start from 0, 0, we ramp it, we hold it, again we retract it and so on. But generally when you are applying a imposed displacement, yeah, it should start from 0, 0 and we ramp it. Now I will demonstrate how to apply imposed displacement in a quasi-static analysis through one example. Go directly to the model. Yeah, this is my model which is fixed at both ends, and I'm applying the imposed displacement through this impactor which I have made rigid. Before applying imposed displacement, one thing should be noted down here is, always when you are applying the loads, it should be applied on the master node of the rigid, because if for this panel, if you are applying loads on every nodes, then it will be something like a pressure load. So to avoid that, you should apply on the master node. We'll apply imposed displacement now. Okay. To do that, you have to go for a utility browser, that is boundary conditions manager. Give a name for that, imposed displacement. Select the type, let it be imposed displacement, and you have to fill all these things. That is, under GR node you have to select the nodes. There are many types. We have to select nodes and select the master node, this rigid. Yeah, selected. Suppose if you are applying the load by considering the global coordinate systems, you need not enter this skew value. Now I will apply through this skew only. So I will create a skew. For that, go to skew here, create a skew. For creating a skew, there are two types. That is, either to create by axis direction or to create by node reference. Suppose if you go by the first option, this will create a fixed skew. And suppose you go by the second option, that is create by node reference, this will create a moving skew. This moving skew is something like a follower force. That is, if this member deforms and moves in a particular direction, the coordinate systems will also rotate so that the load is always perpendicular to the member. So depending on the application, you can select the different types of skew. So here I will go by the first option, that is create by axis direction, that is to create a fixed skew. To do that, yeah, here I will create my skew origin, this thing, x-axis be this thing, xy plane, create. Yeah, my skew has been created, and I will applying my load in this positive z direction. Okay, then you can again select the skew system here. Okay, then the direction here, since I am applying on the positive z direction, I have to select a direction as z and scale x as 1 and scale y as 1. Suppose if you are applying on the negative direction, that is negative z direction, then what you can do is you can give the scale y as -1, so that the function swap from the first quadrant to the fourth quadrant. Okay, now I have to define the curve, new, give a name for that, post displacement, proceed 0 0 0.3 and 100. Since here I am using the unit system of ton, mm, second and newton, what I will do is I will write here as 0.3, that is 300 milliseconds, and this is the displacement, 100 mm displacement. Update. Yeah, my curve has been displayed here. Close. Okay, so to so the click on create option. So to review whether it has been created or not, what you can do is you go to the same location, click on that and right click review. You will get a ping dot, which means that the imposed displacement has been created. Also, there will be a table below. If everything you have done properly, then under the GR node you will get a set ID, and under curve you will get a curve ID, and under skew you will get a skew ID. Similarly, if you want to apply imposed velocity or a force, what you can do is you can just change the type here. For a force you can go with concentrated load, and for a imposed velocity you can go with imposed velocity type. Okay, this is how we can create the imposed displacement in a quasi-static analysis. Thank you.